Another thing is class registration. So in order for you guys to get the certificate, you actually have to be certified. You have to be registered for the class. There's about 10, 15, maybe 20 people who have been turning in assignments and showing up to class who are not registered for the class, right? I have a big master Excel sheet with 80, 85 names, and they are not on there, right? I control F to search your first name, last name, can I find you on there? If you think that's possibly you, please shoot me an email. Also, if again, to go back to the second point in the email, I have attached a note to your first homework assignment, basically saying, hey, you're not registered for the class, please shoot me an email. So, if you think that's you, or if you see that note on your assignment, please send me an email so we can sort it out. I don't want to make any promises, but I'm pretty sure we'll be able to squeeze you into the class because there are a good chunk of people who signed up and haven't shown up to any of the sessions, and there's also a good chunk of people who didn't sign up and are showing up to the session, so maybe we can kind of swap them out. And the last thing, so as for assignment-wise, this is the most intensive week. There's 6 assignments, and they're all fairly simple, but there are about 60, 70 of you. So for me to have to grade 6 assignments for each of you, right, that's, 420 images I have to open up my computer. Somebody did this last week, and I actually really, really appreciated it. I don't know why my computer isn't showing it fully, but you can look at it for yourself on your own. It's basically one big Word document with all the images attached to it. So for this week, we're going to try it out. I'm really hoping that it makes grading a lot faster because I spent way too much time grading them along with the other TAs. So you'll notice that there's only one submission for assignments this week. So you're going to get all your screenshots, fill them onto a Word document / Google Docs, and then make sure that they're in order and then turn them in. And that way I have to open up 6 times less file on my computer, and it should make it a lot easier. So with that being said, if anybody doesn't have any questions, I think we're going to get started with this week's content. We all good? All right, sweet. And again, to remind you, I just started the recording. I'm going to double check on it real quick and make sure that it is running. But for whatever reason, if you cannot make it to a class, we are recording these classes now. Again, we're getting close to Thanksgiving break, so this is when all of our classes start to cram our finals in. So if you have to skip a week or 2 or all of them, this is a resource available to you that you can use. So this week, we're covering a little bit more of intermediate design skills. So the main thing we're going to be talking about is not so much the assignments, but the tools that you use to make the assignments, right? These assignments are going to be very, very simple, and you're going to wonder why we have them, why we have you doing them. But the whole thing about learning CAD or any Fusion or any CAD package is understanding kind of the layout, right? There's hundreds and hundreds of tools hidden within Fusion, and understanding what they do isn't so much the hard part, but it's understanding that they're there and that you can use them. So today's assignments are going to be very simple, but the whole thing is to just familiarize you with Fusion. Where is this hidden in the taskbar so that way you can go and find it. In about 2 weeks, we'll be starting the final project. So our whole goal, hopefully by the end of the day, is to get you really familiarized with Fusion so that whenever we start these projects, you'll have a lot more of a grasp of what's going on, and you have more tools under your tool belt, right? That's the main goal of the day, is to just show you a lot of cool things that you can do with Fusion. So the first one is constraints. You'll notice last week, whenever we were drawing our simple shapes, right? So all the prisms, we would draw a shape and we would give it a dimensions, right? So we tell it maybe 2 inches in diameter or 2 inches tall. So there's 2 ways to kind of constrain things within a CAD software. One of them is dimensions, right? So you're giving them an actual numerical value. And the other one is constraints. So constraints allow you to define a sketch in a certain way, and they're basically geometric relations, right? So I'm going to go on a limb and assume that everybody here passed high school geometry. And if that's the case, then you know everything that I'm about to tell you. This is nothing crazy, nothing revolutionary. The whole goal is, again, to show you that these exist and kind of what they do in a CAD sense. So I have 2 pages of kind of just a quick summary of them. I'll show you some of them in Fusion, but on the right is what the icon is in Fusion, right? Fusion has these features with the icons, not the names. So it's very nice that you get to see these icons, and I would highly recommend kind of not memorizing them, but just kind of taking a look at them, and you'll begin to familiarize yourself more with practice. So the first one is coincident. So that's attaching 2 points together, right? So if you have 2 lines and you want to attach them to the same point, that's what that does, right? So again, very primitive geometry, right? 2 points in space, we're going to give them the same location. Collinear is making 2 lines basically share the same vector. Concentric is 2 circles share the same center, and so on, right? You can read them for yourself, but I'm actually going to go into Fusion in a sec, and I'm going to show you all of them right in front of you. So again, here are some more of them. There's about 11 to 12. You can read some more of these, tangent, for example, equal, nothing super complex. Also, these are sent out in the slides. All the slides that I'm going to cover today, I decided to include them in the email. So if you want to reference these while I'm talking, at the bottom of the email is called, I think, Week 2 assignments, and all these slides are up there with the exact descriptions and everything perfectly. So I'm going to open up Fusion. I'm going to quickly show you what all of these do. Okay. So this is a demo. You can follow along if you'd like, or if you just want to look up at the screen, that's totally fine. So I'm just going to make a sketch. So on the left side is your Create tab. On the right side is your Constraint tab. So the most common ones are highlighted and left up here for you. And the drop-down kind of opens them all up for you, right? So the least common ones. And again, the cool thing about Fusion is if you don't know what something does, you can highlight your cursor over it, and it'll tell you what it does. So the first one, and probably the most common one you're going to use, is a coincident one. So I'm going to make 2 lines. And let's say, for whatever reason, I wanted to make these into a right angle. So with this constraint, I can tell these 2 points, right? So you can tell there's 2 points right here. There's the one on this line, and there's the one on this one. I can tell them that I want them to share the same point space. So with the constraint enabled, I can click on point 1 and point 2, and they snap on perfectly to each other. So if you're making very sporadic shapes and you have stuff all over the place, or if, by chance Fusion doesn't do the auto snap-on, right? I made that mistake last class, and I was going to try to explain this, but I felt like it was a little bit too complicated. So if you're ever trying to do auto snap-on with Fusion and it's just not working, you can just kind of draw the line off to the side, and you can use this coincident, and they'll snap them on together. Another good one is the one just to the left of it, which is the horizontal/vertical constraint. So this is 2 kind of mixed in one. What Fusion's going to do, it's going to figure out, all right, is this line closer to being vertical, or is it closer to being horizontal? If the answer is vertical, let's make it fully vertical, right? So if your line has about like an 85-degree angle, right, it's basically 90. We're going to add that extra 5 degrees, and we're going to lock it fully vertically. So for this one, let's see if I can rotate it. So this line, you can see it's pretty vertical, but it's not fully vertical. So if I do the vertical constraint on it, it locks it vertically. And it does the exact same for the horizontal one, right? If it's within 45 degrees, or if it's above 45 degrees, it's going to make it vertical. If it's less than 45 degrees, it's going to make it horizontal. Another option you have is the equal. So let's say you make 2 lines of different lengths. And this one is very, very, very useful. If you're going to be making symmetric parts, right, which just about most of the things I'm assuming you're going to be making for the final project are going to be symmetric. So if you're making something where the left side and the right side are equal, right, instead of dimensioning the left side and then dimensioning the right side, right, you could only dimension the left side and then set an equal constraint to make everything on the right side equal, right? So here's a really big line, and then we're going to make a really short line right here. So with the equal constraint, we can lock them to each other, and they're now the same size. And you'll notice if I go and I mess with one of them, they'll move together. All right. The next one is tangent. I can explain it if you'd like. Again, tangent is going to take a line, and it's going to make it so that it, intersects a edge of an arc or edge of a circle at one point. Again, if we all passed just basic high school geometry, all of this is very, very similar to you. So tangent does that right there. So you can use it with circles, right? That's what the image shows you. The image is a circle with a line, but it works with arcs. So if you're using like the arc tool or the ellipse tool, right? Anything that just has a simple curve, you can use this tool for. Right next to it is parallel, right? So parallel is going to make two lines go directly next to each other, never touch. You have perpendicular, right? The first four are, I guess the first three are the complex ones. The rest of them, I don't really feel like I need to explain because, again, they're very, very self-explanatory. Parallel, perpendicular, midpoint. This one I will show, and I think this will be the last one I show. So I'm going to make a square, and then I'm going to make a line. So if I want this line to cut halfway through the rectangle or the square, right, I can use the midpoint. So I can tell with my first click, right, I want this object to be halfway between this line. So that's a super useful one that I'd recommend using all the time. Again, equal and midpoint, you kind of use them together. If you're making symmetric parts, right, you can use those to kind of base where your axis is from where your left and right or top and bottom are. And then really quickly, I'm going to cover this one. Concentric is going to align two circles so that their center points are the same. So we have concentric, click on circle 1, click on circle 2, and they now share the same center point. I know that was a super quick demo. If you were watching, that's great. If you weren't, something that you're really going to pick up on pretty easily. The whole point of this was just to show you that those are there so that you can choose to use them for future assignments. You may have to use them a little bit today. You'll use them a lot next week because next week's difficulty definitely ramps up a lot. With that, I think we're going to quickly jump into the first assignment. As last time, I'm going to do it in front of you in probably 20, 30 seconds, and then we're just going to set aside maybe 5-10 minutes for you guys to do it at your own pace. We have 4 new TAs with us. I'll introduce them in a second, but work at your own pace. If you need the time, raise your hand. We'll come over and help you out. Again, we're all students with you, so if you need the time to do work, I encourage that you do homework or anything else in the time that you wait. So this first assignment, I'm gonna open the slides up again, is a constraint. So you're gonna sketch a square, and you're gonna sketch a circle. Give them both dimensions so that they're fully black, right? We covered this last time. If your shape is blue, that means it's unconstrained. That means that it is free to stretch in all directions. Black means that it is constrained, right? You cannot stretch it out. So draw a square, draw a circle, and give a tangent constraint so that it looks something like this. And I'll do it right in front of you just in case you need to see what it looks like. So I'm opening up a sketch. I'm selecting a plane. I am drawing a rectangle out to the side. I'm going to quickly dimension it. I'm going to give it 1.5 inch by 1.5. I'm going to draw a circle out here. We'll give this a dimension of 2. And then we're going to use the tangent constraint, right? So that's the requirement for this assignment. Tangent constraint, we're going to make circle, tangent to that. You'll notice that it's still blue, right? So they're kind of stuck, they're stuck to each other, but they're still free to move around space. So now I'm just going to add a coinciding constraint, and I'm going to tie one of these corners of the square to the center. And we're just going to leave the circle like that. The circle's free to move around, but we're going to constrain the square down. That's all this assignment is. Again, you're going to notice that these assignments are very, very easy. You might be able to finish them in 30 minutes all together. But again, the whole point of today is to show you where these things are coming from and how to use them. So we're going to set aside probably until 5:55 for you to knock this out. If you have a question, you can raise your hand. I'm assuming most of you are going to be able to finish it in probably about a minute. So if it looks like everyone's done, then we're going to move on to the next one. assignment 3 or 4, I'd probably just walk around, look over. There are some people who are they're gonna have issues, but like they're too afraid to raise their hand. So like you walk over their shoulder and it looks like they're just frozen. Just help them out. But this should be pretty simple.
So did the first week like cover shapers and fillets?
That's this week.
That's this week.
Yeah.
So the hammer was last week or this?
The hammer was last week, and that actually the hammer did use fillets. So I guess we cover it again.
But just worried that
Yeah, no, I just think we show. We do it again, but it just shows the difference between shapers and fillets, like what the difference is.
cool. Alright. Did any student have a hard time like downloading Fusion in the first week?
Oh my god, there's so many people here. Took an hour and a half to download Fusion. The bandwidth was destroyed. Horrible. Yeah. I was like, well, we have 30 minutes left in class and we haven't started any of the assignments. This is recorded. I'm sorry, but we're just gonna have to get going. Please just watch the best of your attention. Like, there's something I can do.
With the IPs and all, they have to upload.
Yeah, I'm gonna put a timer. Okay. Also, so I'll put a timer up on the screen. Again, I'm asking that you turn all these assignments in on a single Word document. So if you rip through the assignment pretty quickly, also use this time to kind of make that Word document. This week, in my opinion, is the easiest. The first one's pretty hard because nobody knows Fusion. Hello. You're good. We just started the first assignment. Again, this is being recorded if you want to catch up. I gave them 3 minutes to finish it up, so if you just want to sit down and start from the second assignment forward, I think that would probably be best. But yeah, we're just doing like basic intermediate skills. Thank you. Yeah, this week's probably the easiest because the first week's difficult because nobody knows anything about Fusion.
Yeah.
So like, there's a lot of basic questions. Third week difficulty like goes up exponentially, like out of absolutely nowhere. So like, this is probably the easiest week. Like, there's not a single assignment that you can't finish in under like a minute or two, if you have like a decent amount of knowledge. So this one might be pretty laid back. The next one's gonna be a lot harder.
I like to make a new project, but it's just not getting like made. Like I put in week 2 and then I could just this is hopefully some failed.
Maybe you have too many projects open. What I would do, where's your CAT training one?
Yeah,
Is this it?
Yeah.
Open it up and just
Yeah.
make a folder underneath
Yeah,
it.
that's what I did. But I just want to do something like when I want like do my own pads. Is it because I have this open?
Not too sure. That's just like,
Oh.
yeah, I'm sorry, I'm not too sure.
Okay.
I've never seen that issue before.
Okay, I'll figure it out.
Can't help you. Weird. You guys help me walk around, see if everyone should be done. Just want to see if anyone's still online. Okay, does anybody still need extra time? Again, anybody need extra time? Alright. Sorry, one second.
Can you just dimension the size? I think it might Fusion might have assumed it's a square. Oh, no. Okay, so you want to dimension the other side? Yeah, so go back to the dimension tool. Yeah, and the side. The reason it's black is because the dimension between them is smooth dimensions. And the top is blue because there's no dimension.
Okay, so we are going to get started on the next of the assignments. So all of these are going to kind of build up to us making a gear. But what we're first going to do is we're going to, and this is what this assignment is we're going to be extruding a cylinder. I had a couple questions about the dimensions. These dimensions are from last semester's slides, so you can follow them if you'd like. However, I will not hold it against you, right? If the shape looks correct, that's all good enough. So for this one, we're going to be making a cylinder, which we built off of last week, and we're going to be using the text tool. So the text tool is really good for just like basic graphic design. So whenever you come to your final project, right, some people made like the Purdue train, and so they wanted to put engraving, right? It's like some girl made a train, she put her initial on the back, and Purdue on the side, and Boilermaker Express on the other. So this assignment is going to be using the text tool because we found that a lot of people have used it in their final assignments, and we're just going to kind of familiarize you with it. So I'm going to make a new design, and again, if you want to follow, you can. I'm going to go pretty quickly. I'm going to give you about another 5-7 minutes to run through it yourself. So we're going to quickly make a cylinder. We're going to start off on a plane. Going to make a circle, ground it at the middle. I'm going to dimension it about 10 inches. And then we're going to extrude it outwards just to make a little cylinder. All right. So we're given this. All right. So this is nothing new. We did this all last week. What we're showing you now is the new text tool. So the text tool is hidden under the sketch tab. So to do this, we're going to create a new sketch, right? And we're going to start it on an existing face. So we're going to click on the top of our cylinder, and we're going to start a sketch on here, right? To remind you, you can start a sketch on any plane, and a flat face is a plane. So we're going to start a sketch up here. And as I mentioned this earlier for constraints, right? The most common tools are going to be the ones that are left up here. The least common, more niche tools are typically hidden under the drop-down. So we're going to go under Create, and all the way down here is text, right? This works very similar to a Word text box, right? So you're going to click, and then you drag out, and it makes your text box just like this. And then you're given a little prompt on the right. Again, very similar to how a Microsoft product works. You have what do you want to type? Do you want it bold? Do you want it italicized? What type of font do you want? What type of height? Again, this whole assignment is just basically showing you that this is kind of an aesthetic thing that you can do. So I'm going to be using just the default Arial and all the heights. If you want to mess around with it, I encourage you to. Everything is pulled from just like your very generic Microsoft fonts. So for this, we made the cylinder, we made the text box. I'm just going to type my name. It's a little small, so I'm actually going to increase the height just so that it looks a little bit bigger. Okay. And you'll notice that each of the letters is light blue because it's a fully enclosed shape, which means that we can treat it like any of the other shapes that we've made so far, and we can actually extrude it. So if I finish my sketch and I go into extrude, I can select. So here, Fusion selected everything for me, right? I don't want that to be the case. So Fusion is going to try to help you out by making auto assumptions. If you don't want those auto assumptions, you have full power to override them. So I'm going to click on the X to get rid of everything selected, and I'm just going to select the letters. Just going to change my view. And for this, you can either cut your name out of the shape, or you can cut it into the shape and leave kind of like an engraving. So that's it. You don't have to do your name. You could write something on it. But as for this assignment, pretty simple. That's all that's going on for here. I'm going to give probably about another 5 minutes to knock this one out. Really quickly, I just want to ask, did you guys get the email that was sent out? Yes? Okay, maybe there's something wrong on my side because I cannot see it being sent out, but if everybody here has it, then I think we're good. really weird. I see new mistakes every time. that's why y'all are here. I told you there's weird stuff that happens every time that you've never seen before. Never seen that happen before. Okay, how was the time on that? Does anybody need extra time for that? Everyone good? I quickly want to say, so last time there were a few people who asked me about extra content, right? There were some people who just wanted more practice, and there were some people who just found it very fun and entertaining. In the Slack, when I sent out all the notes after class last time, I attached this resource. One of my professors back in high school recommended it to me, and I absolutely loved it. It's some man's side project over one of the summers, and he basically made 100 days. It's called 100 Days with the Fusion. So each day, it's kind of like what we do here, where each assignment kind of focuses on one task. There's 100 of them. So there's 100 days. Each day covers a specific task. So if you get bored or you really enjoy this stuff and you kind of want a good way to start, that's somewhere that I'd recommend going. So I'm just going to leave it around if you have a little bit too much time and you'd rather spend it doing Fusion, that resource is available. So we're going to go on to the next assignment. I was also telling all the TAs back here, as content-wise, although this is like the most intensive, like numerically wise, it's kind of the easiest. The first week's kind of difficult because not too many of you have used Fusion, so there's lots of road bumps using it. The third week gets very, very difficult out of just kind of nowhere because we kind of have to ramp up the difficulty before the projects. So this week, all these assignments, you're going to notice that this difficulty really is not going to ramp up. The next 5 assignments are going to be very, very, very simple. So just kind of don't focus so much on just completing them, but kind of what you're learning out of them, because before you know it, you'll have to make a whole assignment, and kind of falling back on all of these tools be really, really good. So next, we're going to be doing some touch-ups, right? So if you're making a final product, the 2 things we're going to be talking about is chamfering and filleting. These 2 things are pretty good in your you're going to find them more so in your like industrial/mechanical side of engineering, right? So if you're going to be making a table, you don't want a table to have super, super sharp edges, right? If somebody falls and hits their head, that's just a lawsuit waiting to happen. You can look at the tables in front of you. The tables actually have that rounded off edge, right? That's a fillet. So fillets and chamfers are kind of a technique that manufacturers will use to either reduce weight or kind of safeten up products. So fillets are going to give rounded off corners to edges, and chamfers are going to kind of cut an edge right down the middle. So I'm going to quickly show you what these do. Again, I'm going to run through it pretty quickly. Shouldn't be more than a minute. We're going to make another rectangle, or we're going to make another cylinder. So I'm going to copy the same dimensions that I used last time. So you go 10. We're going to extrude it up about 3, right? And then we're going to cut a little piece out of it. So I'm going to open up a new sketch. I'm going to make a circle over here, and I'm going to use the coincident tool. So I'm going to snap. I'm going to open that up, and what I'm going to do is I'm going to snap the center of the circle to the outside of the bigger circle. So I'm going to click on this circle right here, and then this one right here, and you'll now see that the center point of the smaller circle is now snapped on to the circumference or outside of the bigger circle. So I'm going to quickly dimension this. Again, dimensions are not critical in this class. I'm just going to give it some sort of value. So we're going to do 2.5, and then we're going to quickly cut this out. Okay, so now we're left with a shape like this. Okay, so under our Create tab right here is where we're going to find, right, this tab right over here is where we're going to find our chamfer and fillet tool. So under Create, we should have, okay, apologize, I'm mistaken. They're over here on the Modified tab. So the fillet tool is on the top, but the chamfer tool is hidden underneath in the dropdown. So we have 2 edges to our circle now, right? We have this sharp edge here, and we have this sharp edge here. So we're going to apply a fillet to one, and we're going to apply a chamfer to the other. So I'm going to select the fillet tool. I'm going to select one of the sharp edges, right? So these two, they only work on edges, right? You'll notice that I can select these faces, but you want to mainly apply them to edges because you want to be smoothing off your edges. So I'm going to select one of the sharp edges, and you'll notice that you can either enter in a value onto the right or you can push the arrow. And it's going to apply a radius, and it's going to smooth off that corner. So this is something that's going to kind of go into the design of your ladder project, right? Doesn't really apply too much use for the stuff that we'll be doing for the rest of today and tomorrow, but whenever you come to make your 3D parts, this might be something that you may use a lot. So I'm going to push OK. And then for the other one, I'm going to pan over to look at the other side. We're going to do the same thing, but we're going to be using a different tool. So modify, chamfer works the exact same way, but it has a different effect. So the menus looks the exact same. So we're just going to select one of the walls. You can either type in your value here, or you have this arrow here. And you'll notice, I'm going to push OK, I'm going to do a top view. You can see the difference between them and what they do, right? One of them is going to give this arc, and the other one's going to give that nice sharp cut down the side. So that's this assignment. I'll put up another 5 minutes to quickly knock this one out. Right. Yep. Yeah.
So, for week one, I made the hammer, and in the video, for the assignment itself, I think you didn't have to follow the edges. But then for the video that I watched, because I think the last, I think he kind of sped through the last section, so I rewatched the video.
Okay.
And in the video over here, it says that you have to follow the edges.
Yeah.
So, but like I didn't get the points for this. I got 2 out of 3. So.
What's your name?
Tejas. Tejas.
I need to unplug my computer because I don't want to show everyone. I made that mistake multiple times. I probably gave you full credit in the actual grading, but I accidentally returned you the wrong. What's your last name? Yeah, you got full credit. That's I made a mistake typing it back. No, you did well. That was my mistake. That's happened like 3 times already.
Thank you.
All right. Yes. Also, really quickly, whenever you take the screenshot for this, please make your view look along the lines of this, right? Your view looks like this. Can't really tell what I'm looking at. So just whenever you take the screenshot, just please include this in your view, right? Just the fillet and chamfer. You do the fourth week is final projects. The third week, yeah, you just do 3 final projects to just teach you like it's like I sent out a feedback form at the end of the last class. Like the negative section was just like week 3 sucked, week 3 sucked, week 3 sucked.
I love week 3 because we have to do the airplane one, and that was
A lot of people was like it was really nerve-wracking having to work at that speed, and I was like, yeah,
I mean,
that's what
yeah,
happens when we
'cause-
have 5 weeks. It's just like the speed has to get ramped up eventually. And it's
week
just,
2 and week 3. There's a huge jump.
yeah, this week's the easiest.
Yeah, I guess.
Okay, there's 3 left. Look at that. Okay, so we're going to move on to the next one. The next one is this little gear looking shape. So our focus on here is showing you the different pattern tools of Fusion. So for this, instead of making a new cylinder, it's getting kind of redundant. We've really prefaced down here this little timeline, right? It's awesome. If you push play, it shows you kind of like how you made your thing. So whenever you have like your really big complex models, it's really cool to see how you've done. So for this, I'm gonna go back and I'm actually gonna delete all of these features because I'm gonna be starting from the same point anyways. So I'm gonna go back and I'm actually gonna delete all the progress that I just made. And we're gonna start from here. So we're gonna be making a gear, and instead of trying to make all the teeth, right? This is a fairly simple gear. The one that I made has 9 teeth, right? You can make 50, 60 tooth gears. Having to model the same shape over and over and over again is just very, very redundant. So if we can just make it once and then make it a pattern, right? We can save ourselves a lot of effort. We make the computer do all the work for us. So that's our goal with here. So I'm gonna start up a new sketch on the top of the cylinder, and I'm gonna try to make a gear pattern. So something that we haven't shown you yet, and it's honestly my favorite tool in any CAD package, is the construction line. For Fusion, it has it really readily available. Other packages have it kind of hidden, taking 163 right now, and it's kind of a burden to get access to. It's a right click and a whole menu to access. Right here, it's a good button on the right side of your screen, so it's really easy to get to. So what construction line does, right? So I'm gonna draw 2 lines, and you can quickly see what the difference is, right? So that's a normal line, right? It's light blue, and I'm gonna make a construction line, right? You'll notice that it's an orange color, right? So what these constructions lines do is they are kind of reference. So like if you're ever doing like a homework assignment, you know how like you'll kind of jot down notes on the side of what's going on. That's the same thing. So if you ever need to like kind of jot down references or kind of frames for yourself, right? These reference lines kind of constrain stuff, but they're not actual lines, right? If I made a square out of construction lines, I couldn't extrude it because it's not a closed shape, right? They're simply there for guidance. So it's generally a pretty good practice to kind of overuse them. Obviously, use it with a grain of salt. Don't put hundreds and hundreds of them. But the more construction lines that you put, right, they're guide rails for you. They kind of help put the form together of the shape. So for this, whenever I did it back in my apartment, I used a lot of them. That's kind of how I was taught to do fusion. I use them all the time. So I'm gonna make one of the gear teeth, and I'm gonna try to use as much construction geometry to kind of help me out. So the first thing I'm gonna do is I'm gonna make a line, and I already have it in construction, right? It's highlighted, and I'm gonna snap on to the middle, and I'm gonna draw outwards. Okay. So now I'm gonna make another line. I'm gonna go to the middle of this point. I'm gonna drag out a little bit, right? So this dotted blue line kind of follows my cursor. And you'll notice that I unselected the construction geometry. So you'll kind of tab in and out between them. So I'm gonna make a construction line. I'm gonna reference it a little bit. I'm gonna make another construction line. I'm gonna reference that a little bit. So you kind of go back and forth, and it really helps you put the big picture together. So I'm gonna make a line connecting to there, and you'll notice this little T shape. So it's perfectly perpendicular, perfect. It's exactly how I want it. So the next thing I'm gonna do, I'm gonna make another line. I'm gonna snap onto my empty point, and I'm gonna snap it onto my circle. So now I just have this. I'm gonna throw some dimensions on here. So I'm gonna give this length to be 1 inch. And then I'm gonna give this angle to be about 105, right? So you'll notice that it's still blue, and that's because I can move this top part, right? There's no dimension lengthwise. So what I can try to do is do a sketch dimension. I can dimension this to the outside of the circle, but it's only gonna let me do the center point, right? So what happens if I wanna dimension this line to the diameter or the outside of the circle, right? It's not gonna let me. So what I can do is I'm gonna make another line. Gonna do construction. And this assignment has a lot of variability. You can make it however you want, but again, I'm just showing you how I do it. I really like using this construction geometry. I'm gonna make a straight line, just like that. And I'm gonna put a tangent constraint, and I'm gonna attach it to the edge of the circle. So now, right, since the line is tangent to the circle, if I constrain this other line out in space to this line, I'm constraining it to the edge of the circle because it's tangent. So now whenever I go to dimension, it's not gonna tie me to the middle of the circle. It's gonna let me hold it like that. So now I can throw in a value. So I'll throw in 2.75, and it's black, which is what we want, right? It's not gonna move anymore. So I only have half of it. So what I'm gonna do, right, the big premise of this whole assignment is letting Fusion do the work for you. So we're gonna let Fusion do the work for me, and we're gonna let Fusion make the sketch that I made. We're gonna mirror it over this middle axis. So right here, next to your dimension, is this mirror button. So I'm gonna click on it, and I'm gonna select my 2 lines, right? So you have 2 prompts. Prompt 1 is objects. So select my 2 objects, change prompt over to prompt 2, and now I need a mirror line. Coincidentally, I have this line that I drew originally. I can select that, and it'll mirror it over that center. And now I've done all that work with about half the effort. Now, to be even more efficient, I'm gonna take this one gear piece, right, and I'm gonna revolve it around the outside of my circle. So what would have taken me maybe 20, 30 different lines and 20, 30, 40 different dimensions, right? I did it with 2 lines, 3 dimensions, and then under create, we have our circular pattern, right? Underneath it is rectangular pattern. If you can catch on how circular pattern works, you can catch on to how rectangular pattern works. So you can kind of use both of those now, right? I'm showing you where these are, so you can use them in future assignments. So circular pattern, they both work the same. You're gonna select your objects, and you're gonna select direction. Circular pattern is gonna be radially. Rectangular pattern is gonna be linearly, X, Y, Z. So I'm gonna select my objects. I'm gonna select my 4 lines, and I'm gonna select my center point, right? So I'm gonna move over to prompt 2, and I'm gonna select my center point. And now I can increase this number as I'd like. I'm gonna move it over to 7. And now we've made a whole gear with pretty minimal effort. And now to finish it off, all I'm gonna do is I'm gonna extrude all of these. A cool thing, haven't really spoken about it much. Under extent type, there's lots of options. Something that I really like to use is the toObject. So instead of typing in a value, you can say toObject. So I can say extrude this profile to this object. So it takes that dimension from the Fusion file instead of making you type it in. So I'm gonna pan over so you can kind of see what's going on. So I changed it to object. My prompt is now object. I'm gonna click on this bottom face of the circle, and it's gonna extrude it all the way to that object. It's gonna make the full shape. Push OK. And then the last thing we're gonna do is we're gonna add a hole. Really, really, really good practice. Do not draw a circle. If you're ever gonna make a hole, do not draw a circle and extrude it, right? It's just a very bad practice. If you're ever gonna send out a part for manufacturing, that loses the computer or whatever it is, right? If it's a CNC computer, if it's a 3D printer, whatever type of computer-controlled manufacturing unit it is, you lose that computing unit a lot of information, right? This whole tool, right? This whole hole tool is there for a reason. What this does, yes, it's a little bit faster than drawing the hole and extruding it, but what it does is it holds a lot of really valuable information for the computer. So, really good practice. Anytime you're gonna make a hole in any part, use the hole tool. Because whenever you go to manufacture it, it saves the computer from getting errors. So, we're using the hole tool. The first option is face/sketch points. So I want to put it perfectly in the middle. So I'm going to select my face, and it's going to place the circle kind of far off in the middle. It's not really where I wanted it. I can grab this, drag it to snap onto the middle. Here are your dimensions if you want to change the depth, right? I want to through all. As of now, it looks to be through all, right? I can see the other side. Here, if I want to make the dimension or the diameter smaller or bigger, so I can do 4.5. Then we'll push OK. And that's all that there is for this one.
But the easier way and the way that we're trying to teach you is to use the that there are like too many points. So offset will replicate feature, and you can either stretch it. a sketch. It's a little blip that you have. I think Fusion does it so. You have to find the icon, and it is really hard to find. You have to find your original one and just zoom in. You know what it looks like, right? When you go to search the pattern tool, take a look at what it looks like. Yeah. You have to find that icon and double click it. I think Fusion does a horrible job of editing this. Yeah, you have to find the icon somewhere on your screen. Yes, though. It's gonna be somewhere. Mike is that it's gonna be on the original. Yeah, that's it. Double click it. There, yeah. I hate it. So it just follows along. Complex sketches, so simple. You give like one dimension, the whole thing has zero.
No, I just. Oh, you're good. Thank you. Yep, of course.
So you'll notice, again, we have 2 more assignments left. We're going to do them together because one of them is literally a single step. All of today is just a little bit more theory-based. So if you have any questions, there are 5 of us, so I really recommend you raise your hand, call one of us over, ask us your question, or you can say after class, right? Just understanding and getting the full grasp of these concepts will help you a lot more later. These assignments are super, super simple, and I kind of find them boring, but we really just want to show you that these things exist, right? Just another tool to put in the toolkit, because whenever you come across a big design problem, how do I make a monitor? Whenever you have, multi-dimensional, multi ways to solve, whenever you have multiple ways to solve a problem, you can typically start to find the better one, and the more streamlined, the more optimized one, and the more stuff that you know how to do in Fusion, the more doors that are gonna open for you. Okay, so we have about 50 minutes left in class, and there's 2 assignments left. I'm going to do both of them right here, and then we're going to open up the floors to the rest of you. So again, I'm going to start from the same sketch all over again. I'm going to delete these, and we'll start with the plain cylinder. So under create is thread, right? So thread is right underneath hole. So hole and thread are, again, as I mentioned earlier, they are more compact informational ways for you to tell the computer what you're trying to do with this model, right? So if you're gonna manufacture something like an assembly, or if you wanna make a desk, you wanna manufacture something that's gonna be put together, you're probably gonna need to use nuts and bolts, and you're gonna have to apply threads. So the assignment 5 is just simply applying a thread tool to a cylinder like this. So all we're doing is we're going to this thread tool right here, And it works the same way as the whole wizard. So you're going to select a face. Shrink it down. It's odd. One sec. It's really odd. What?
Because there's no hole.
Oh, yeah. Okay. Good call. Okay, so in order to make a thread, it's in the instructions, but you'll notice a thread needs a place to exist. So the first thing you have to do is you actually have to make a hole, right? The error that I was coming across was there is no hole present in the part, so Fusion just assumed I wanted to make the whole thing a thread. So you need to give like a nest for the thread to be created in. So we're going to go back to the hole tool, and just like we did earlier, we're going to add a hole back to the center. And now, whenever we go to create and thread, right, we have a nest for this thread to be created in. So whenever I click on this face, we get a thread created. Everything on the right is super specific for manufacturing. I'm not going to try to get into trying to teach it because it's just a little bit too complex. But if you ever go to Home Depot and you want to manufacture like a part for your desk and you buy like 1/4 bolts at Home Depot, right? You can look that up. You can find out the thread size so that you can 3D print a proper part where the bolts that you bought from Home Depot or Lowe's can thread into that part. So all of this is just like real life dimension specs. We don't need anything fancy. We're gonna put the generic ones, we're gonna push OK, and that's the 5th assignment. So the 6th one is gonna be using the offset tool. Okay, so I'm gonna start off with a new sketch, and I'm gonna make a rectangle grounded at my center, just like this. And I'm gonna give it some dimensions. So we're gonna give it 2.75, and then we'll give it a length of 5.5. All right, so as I showed you in the 2nd assignment, right, there is a fillet right here, right? So we are outside of a sketch. There's a fillet option right here. If I open my sketch back up, under modify, there's another fillet option. So you can either fillet your sketch or you can fillet your extruded body. Now that comes with like the theory behind design intent. So how do you want it to actually act? They're both very viable option, but if you're looking very long term and you feel like one is better than the other, I encourage you to use that one. But we're just showing you that there's 2 ways to do this. So we're going to add a fillet to the sketch, which works just like the other one does. So we're going to fillet off this corner, and we're going to use the offset tool. So this modify tab is super useful. My biggest advice for learning CAD is really learning all the tools to it. So constraints, super useful. Construction lines, super useful. Those 2 in combination can basically allow you to make a super complex sketch. You use 1 dimension and the whole thing turns black because it's fully dimensioned. The modify tab, if you make really complex figures where you have circles interlapping and lines crossing across each other, right? This allows you to extend features, cut off features, right? So this is kind of like taking a pair of scissors or taking like a pencil to a fusion drawing. So we're going to use the offset tool, and I'm going to select this profile. And what the offset tool does is it makes a replica of what you select, and you can either grow it or you can shrink it. So if I want to make a hollowed out feature, right, I'm going to give an offset position of 0.45, which okay. So what this did is it saved me a lot of effort. If I wanted to make this shape all over again, and I'm actually going to make it a little bigger if I can, because it doesn't show the radius too well, but if I wanted to make this shape all over again, I'd have to make another square, I'd have to give it 2 dimensions, and I'd have to radius it all over again, right? So that's 4 steps. I did all of that in 1. And it makes saves you a lot of time. So last thing we're gonna do is we're gonna do a sweep. So what we did in the first lesson with the pencil. So over here with the revolve, we're gonna take the outside profile, we're gonna revolve it around our middle. And for the screenshot, we want to show that it's actually hollow. So there's multiple ways to do this. You can do 180 degrees, right? So we're only going to revolve it halfway. You take your screenshot like this, awesome, you're done. Or another technical way, right? So if you want to make a really complex part, and eventually there's stuff in your way and you want to examine the part, under utilities is this thing called section analysis. So section analysis allows you to make a plane through a feature, and everything that is on one side of the plane will cut off. So if I do a section analysis and I select, I'm going to turn the body off, and I'm going to select this middle plane, and I'm going to turn the body back on. You'll notice that it cuts it right down the middle. So if I'm going to be tweaking with stuff inside the sketch, I'm going to push OK. I now have a new drop down over here. It's called analysis. So if you're going to be making something really complex like a car, and you actually want to put like details inside of it, this is the way to do it, because you can put a plane through the middle of the car, you turn it on, and it cuts the car in half. And now you have access to the inside. And let's say it's annoying me, I want to get rid of it, turn it off. So that's two ways. The goal of this is to get this type of screenshot. You can either do it just the easier way by revolving it only halfway, or this is one of my favorite things to do, is the section analysis. Again, when you get really, really, really complex models, really helps you take a couple steps back. It's like, okay, a little overwhelmed, there's too much on my screen, let me just focus on what I want to focus on. And yeah, that's the end of this week's course. If you guys are done, you're more than welcome to leave. And yeah, we're going to be sticking around until the end of class at 7:30, so you can stay around and ask questions and finish up your assignments while you're here. Another thing I want to mention before we all go is just the Slack. I have no issue with you guys like shooting me DMs with questions, but many of the questions are very repetitive. So if you have questions, I really want to encourage you sending them in the Slack. Slack's a little weird. If you go over here to add channels, all the channels that I created are actually hidden. So I have one called assignments and I have one called announcements, but they're hidden for you. So if you go to add channels, you can add assignments and announcements. So if you ever have any questions, or if I ever need to make an announcement, that's where they're going to be posted in. Just kind of spreads out all the news from general. And that's all that we have for this week. This week was very simple. I'm going to give you a pretty big heads up. The next week difficulty goes up like 20-fold. I'm not too sure why, but week 1 is teaching you Fusion. Week 2 is showing you where a lot of stuff is. And then week 3 is working on other people's past projects to give you a scope of everything. And then week 4 starts the projects. So this one was kind of a break. Hopefully you guys could have used it well, but just giving you a pretty fair heads up. The next week is going to be pretty intensive, and we're probably going to use the whole 2 hours for sure. So that's all I have to say for today. Thank you so much.